morning, everyone. Myself, Bhavik Shah. I'm a technical leader in Cisco, currently in CX security. Basically, what I do is I look into the enterprise security solutions. We have for a product called Secure Firewall, which is our product, a firewall solution. I am sure many of you would have heard about the firewall, but nonetheless, even if we are not going to touch upon that, I know that today's session is on AI and cybersecurity, but I believe those fundamentals are equally important in order to understand how AI can leverage in cybersecurity, right? Yeah, that's what I do. Basically, I look into larger enterprise deployments, look into their problems, what problems else they face, and then accordingly troubleshoot at the application layer or at the network layer to understand what are the different challenges they are facing, and also at the same time, if there are different features in which a particular product is supposed to work, if it's not working, then we I troubleshoot and also try to bring the resolution as fast as possible, right? So that's what I do. That is my primary forte, or I would say that's the primary bread and butter that I need to do daily. But apart from that, I like to learn new things. I like to learn new skills because in this evolving technology world, you would know better than me because you would realize that each single day there is something new to learn. And if you are rigid to yourself, if you think that you know everything, then that's where you fall apart. So that's what I do. And I keep on learning new things. I keep on, contributing to this community like this in whatever small way I can. And at the same time, I also like to learn from different bright minds like you. And it's always mutual in this big cybersecurity community where you learn something and also at the same time you strive to give something. So that's what I have done. So till now, basically, in cybersecurity space, I have led two CTF tournaments back in 2020 and 2021. I'm not sure whether you were able to attend the SecCon, which we used to have every year in October, November. So basically, I built a team of 4 or 5 individuals, and then we hosted CTF, Jeopardy CTF for 2 consecutive years, and we had like close to around 1,000 to 1,100 participations across Cisco. And obviously, there used to be participation from bright minds like you. So that is something which I have done. Apart from that, we did Cloud CTF last year, last year, which was the first of its kind. I know there are different Cloud CTF events which run externally, but in Cisco we did it for the first time, and we also built the platform. I would share the GitHub link for that. You can have a look. So that platform was nothing but an integration with CTFT, which was a front-end UI. CTFT, I am sure many of you would be playing CTF. So it's an open source UI or an open source platform which you can use. So our front end was CTFT, but the back end we use Kubernetes, we use Terraform. The reason we did that was because what we did was the kind of the challenge or the kind of the framework which we architectured was that you log in to the CTFT with your AWS account which you create. You need a free account. And once you give your account ID and secret key, basically what we do is each of the challenge, when you click on deploy, each of the challenges gets deployed to your tenant, to your AWS account, and then you need to find the flags. So basically, each of the challenges had a vulnerability. So it was a kind of attack defense, but within your account, and you find the vulnerability, and then you get the flag. So it was well received. And as part of the innovation which we do, so we also submitted this framework as part of Stevie Awards. I'm sure you won't be aware of that, but Stevie Awards. So Stevie is an award, is an industry recognized award which is given to an organization for the excellence which you do in the innovation. right? So that's why we submitted this cloud CTF framework, and we got a Stevie Bronze Award in 2022. So that was, I mean, like around in, so it's an pan-India event. So everywhere, each of the organizations in India submit their entries, and then there are line of judges, which through which you have to go through. So yeah, it's something which was a proud moment. And apart from that, yeah, I have spoken in different avenues like Null Communities, the Seasides Conference, which happens in Goa every year. And apart from that, I've been a speaker in Offensive Summit, which we have internally every year in Cisco. And also, I like to spoken in different universities like SSN. I've spoken before too, but apart from that, I recently spoke in ISC and Kerala universities. So yeah, that's what I do. And yeah, my primary interest area currently lies in cloud security. But apart from that, I like in malware analysis or the reverse engineering, something which I'm always keen on learning skills and also improving myself. So yeah, I hope it was not the long intro. And this is my Twitter handle. I mean, feel free to connect. Yeah, I'm not posted for many long time, but yeah, I will make sure that I do it more frequently, and that's my LinkedIn profile. So, couple of housekeeping stuffs, right? Um, I want this session to be interactive, and that's a reason why I've just kept minimum slides. I know that art of AI can go a bit theoretical. I just made sure that it's not that theoretical because I myself, be as a student or now as a professional, engineer, I also don't like long theory lectures, right? Because my attention span is very small. So that's what I've made sure that I've kept the content very less because it's not practical to cover all the nitty-gritties of artificial intelligence in in a 90 minutes lecture. But I made sure that whatever we discussed here, at least it opens the gates for you to start thinking more and to start thinking in different directions. At the same time, I would like different questions. And even if you don't ask me questions, I just made this quiz, a small quiz, which we would, which every one of you uh, can log in, and I would just give a specified amount of time so that every one of you can at least answer so that we can understand that okay, what's the understanding level, and then we can discuss from there. So this is so you can log in from your laptop or from mobile phone, and this is a URL and this is a code. But yeah, not for now. But I think I think the first question we can do that, right? So can all of you log into this minty.com, and this is the code. And then I would start the quiz. So the first question, so that if anyone is in sleep, uh, we can make sure that everyone is active. Uh, so can let me know if you have any challenges in going to this. So this is a code 33706426. So go to menti.com in your mobile phone or anything. And yeah, so you need to give your answer. Thanks, Sakshi. Uh, the first housekeeping stuff is don't uh, write your name on this. Just kidding. But yeah, good to know. Yeah, so I'm just waiting for answers. It's um just just to just an icebreaker session, right? Just to make sure that what do you think of artificial intelligence? Again, you can say what is artificial intelligence in cybersecurity, or in general, what do you think about artificial intelligence? Obviously, In last 2 months, there has been a lot of talk around it, right? So yeah, solving problems like humans, absolutely. Copy human intelligence, and I'm sure you would have heard about ChatGPT, right? Or now from Google, it's Bard. So absolutely. So basically, the reason they are using artificial intelligence. So I was reading about this interview from Sam at Altman when he came to India, and there was this Times of India session or a question answer session with him. And one of the basic question or everyone has on its mind is how can AI affect our jobs? And what I mean, in a subtle way, what he answered was that yes, AI might impact the jobs which we're here doing today. But what he clearly I mentioned was that there is always like the way there was an industrial revolution where the manual tasks were being replaced by computers. Similarly, this is another machine level revolution. I mean, on top of the industrial revolution, more importantly, AI would improve the quality of life. And what it would do is basically it would increase the productivity, including us, and it would allow us to think more, right? So he basically answered in both the ways. So that was very intriguing to hear from him. But yeah. So yeah, I think pretty much of us understand the advantages of artificial intelligence and what it brings to the table, right? So yeah, it's basically imitate what we think as humans, or how to solve the problems like humans, or how to give answers which feel like it's an answer given by a human, right? So absolutely. So yeah, that is good. So perfect. I think yeah, we are good here. So I will go back to my slide deck. So there are other questions which should come to it at the appropriate time. Okay, so that brings us to ChatGPT, right? Or search engine. So this slide basically talks about uh, before ChatGPT came, right? The only thing what we had, like maybe for last 15 years, was a search engine, right? So we had this Google search engine on the left, where we used to put any queries, be it answers for our assignments back then, right? When I was a student, I remember that when I had to submit our final year project, we used to research different things. We used to understand that, okay, what are the problems the industry is facing? So we used to use this cool search engine, and then depending on the queries, reading the different responses, and then used to build our proof of work, or used to think of our ideas on which domain we need to work, right? So that was Google search engines, right? Now, back how if you I'm not going into the details how a search engine works, but you would have heard about the term called SEO, right? Search engine optimization. So what it does is basically there's a crawler on the search engine. So depending on the query which you or depending on the input which you give, what that crawler does is basically it takes your input, maybe it breaks that input in different words, and it looks for all the data which is available on the internet in the form of websites, right? So as part of SEO, you had certain guidelines how you construct your web UI. Basically, you need to make sure there's several headers which can help Google to get your search results or the results from your website at the top, right? So that's what it used to do, right? SEO. So basically, for example, if you say that I want to understand where the post office, or let's say where the post office is located in my location, right? So what it would do, two important things is it would look for post office keyword in all those websites where it is being referenced, and second most importantly, it looks for your location. It gives you a location based results. so that it's beneficial for you. So, say for example, if I'm sitting in Bangalore, I would be more interested to look for all the post offices which are in the nearby location in Bangalore and not something in Kerala or Chennai. So that's what SEO used to do, right? Now with this chat GPT, right, what it does is it it everyone is saying that it would replace a search engine, but not going into that discussion. But now what it does is, I'm sure you would have seen the ChatGPT terminal. If not, I would show you in some time. But what ChatGPT does is it's basically a command line or basically a terminal based tool where you ask your queries, right? So when you used to ask your queries in the search engine toolbar, now you post your queries in the ChatGPT tool, right? And what ChatGPT does is, again, it does the same thing, right? It has its internal algorithm base place. What it does is it takes your input, divides those inputs into different words or breaks into different letters or words, and then it feeds into the different human-based algorithm which it has created by different scientists. And what it does is then it looks for all the data which is available on the internet, the way SEO used to do, and it gives you pointed responses, right? So, say for example, a simple example, like many of you would be doing coding, right? Uh, I mean, you can unmute yourself. How many of you have used ChatGPT uh, before the session, or at least have started using it, or getting a look and feel for this? You can continue. I mean, once the moderator is there, they can unmute and you can speak. But assuming that at least you would have heard of ChatGPT, and today we would see how the UI looks again. And we would not go into nitty-gritties, but one of the examples which I wanted to give is I would actually give a practical example, right? So last year, we wanted to build a tool which would basically do different manual jobs for you, right? So one of them was, so we as an organization, we have 50 to 60 individuals as part of our team, because that's how our team is, right? Larger team. Now, one of the challenges what we faced was, um, as so we have different cloud resources assigned to us, right? AWS, Azure, and GCP. So generally, most of them uses AWS depending on the requirements. But what I do is, like, let's say we have a tenant which has been created, and we create a user as part of that, right? So we log in with that tenant, that admin user, and then we start using different resources or different services which we want to deploy in the AWS, right? But one of the challenges is when one of the engineer goes away or leaves a team, right? We have no accounting that how many resources he has built, how many services which he has built is still running, and is it required or not? Because each of the services, when they are running, they build to your organization, right? So one of the problem was how can we cut down those billing cycle? How can we cut down those larger infrastructure costs, right? And one of the problem was how do we monitor this, right? And that's where we came up with this idea that how about building this script on top of that, a Python script, which would monitor this, and at the end of the day, it would just give a list of resources to an admin that each individual has deployed which resources, right? And it's the job of the admin to see that if that individual is part of the team or not. And if he's not part of the team, he can just, as part of the script, he can just say that, okay, go ahead and delete this resources. Now, as part of this plan, right, we dedicated ourselves 1 week of time to build this script, okay? Because, again, we are not efficient coders like you. But let's say told ourselves that, hey, we would give 7 days of uh, dedicated time and we would build this module. The first day when we said, we just heard about ChatGPT 2 days back. That's when OpenAI launched to the entire world. And we started using it. And believe me, the 7 days of work was just done in I would say 4 hours in a single day. and we got obviously the code which the ChatGPT gives, you need to modify. It won't run the way it is being listed. But what I'm trying to say is basically it just saved the time what we were doing, right? Which means that what ChatGPT did was, if I was able to open 10 Stack Overflow pages for different queries which I had, what ChatGPT did was it basically articulated or basically looked at all the 10 Stack Overflow pages and just gave one final solution of how the code would look like, right? Obviously, there were errors in that, and it took time to fix that. But the 7 days of work which we thought would be finished was just finished in 1 day or four, right? So that's the power what ChatGPT brings us. Obviously, there are disadvantages like it requires more compute power, not from an end user perspective, but from the system where they are being deployed. And in as part of a chat GPT, the data which it relies is on the internet, right? It relies on the internet, and it also relies on what kind of queries you are asking to the search engine, right? So on the left side, when we used to put queries on the search engine, it is you as a human who used to put different queries, and depending on that queries, the search engine used to get the response for you. Similarly, ChatGPT relies on that and kind of queries which you are asking on the internet. That is one dependency, and the other dependency is obviously all the internet kind of data. So say for example tomorrow, if there's no data on the internet, or all the data on the internet is hacked, then ChatGPT is of no value to you, because it does not generate data on its own. It just builds a context around the data which is available on the internet, and it gives you a response depending on the query which you ask, right? So does it make sense till now? And believe me, in ChatGPT, you need to ask right questions, right? If you don't ask right questions, you're not going to get right answers. Similarly, what we used to do in search engines, right? If you ask specific queries, then you get the responses faster. But if you ask, a query which is not to the point, you would get answers at a very delayed space, right? So that those commonality remains, but that's what ChatGPT is about, right? I would quickly show you the console and then we would move down. So as you can see that these are my past queries which I put, right? So as I was saying, this is a project. Just a minute. It's asking for. Okay. So as you can see that it's a terminal based. So you put your queries here and then it gives you a response, right? So this is specifically what I was talking about, the project which we built, right? Where we dedicated ourselves 7 days, but it was being done in only a single day. So this is how it gives you a response. You need to ask specific questions, that how do I extract flow logs with specific IP on AWS, and it would just give you all the steps, right? So basically all this data it takes from the internet, from different Stack Overflow pages, right? But basically it gives you the response in a concise way, right? So that's the beauty about ChatGPT, where you get the framework on what you need to build, but obviously you need to make changes on top of that. Okay, clear? Any questions? So I'm sure many of you would have used ChatGPT, right? Yes, no, or this is the first time you're seeing the console.
Sir, most of us are familiar with the chat GPT.
Okay, fine. So yeah, I mean, I would, yeah, I mean, it really helps you in all the monotonous work you do, the repetitive work. It really helps you in uh, not wasting that much time in doing that, and basically putting the time more efficient time on doing more efficient stuff, right? So that's where it helps. So yeah, coming back to our discussion. So yeah, that's the difference between the search engines and ChatGPT. So that's how, as I mentioned, right? So initially we used to put this query in the search engine, what SEO or the search engine optimization, which was the underlying algorithm, which most of the search engine or Google deployed was. What it used to do is it used to use a keyword AI and used to see in all the websites which are being deployed over the internet, right? So that's what it used to do, and that is what the response used to look like, right? Coming back to ChatGPT, your search engine is now replaced. It's a text-based response where you put your query here and then you get the response like this, right? So as we just now saw on the console, this is a text-based tool. I mean, obviously going forward, they would have image-based where you can give image as an input and then it would generate the responses accordingly. Now you would have seen different I think, ma'am, now you can mute if they are not speaking. I think when I want an interact because there's a disturbance which is coming. Uh,
Yes, sir. Good.
yeah, okay, thanks. So, yeah, so it's a text-based tool, ChatGPT, right? And I think Bard, I have not used it, but it looks to be the same. But going forward, you can give input not only as a text, but you can give input anything, right? Be it an image or anything, right? So this was what I was asking, right? That okay. So uh, that's where we are, right? That there are many discussions which are happening, right? That would ChatGPT replace the SEO? And this is the question which I asked ChatGPT itself, right? And you can see that it has its own version. It says that both of them has its own value, where search engine optimization would continue to have its impact, and ChatGPT would also have continued to have its impact in different ways, right? So both are going to coexist here. Again, the idea of this talk is not about to have a discussion on this, but I just wanted to have an understanding, right? Because when we talk about ChatGPT, we are no longer using our search engine optimization. Does that mean that is no longer required? The answer is no, right? So So what is the underlying architecture of ChatGPT, right? So it's based on a large language model, right? And obviously there are different versions which come with GPT. Like when it was launched, it was 2.4 or 3.0. Now it's cheap. Now it's 4.0, the version. But the underlying architecture, the underlying model is based on large language model. So what is a large language model, right? So it's basically the picture which it shows here. It's nothing but is you can consider it's a representation of our brain. Now everyone of you would be knowing this that our brains is a mesh of different neurons which are connected to each other, right? And our brain gets a electrical signal on our brain, and that signal is passed to our different neurons, and that's how we make a decision, or that's how we act upon different challenges, right? Or react to different challenges, be it emotional, or be it in professional world, be it in sports, or any activities. What we do, it's always a signal which is being generated to different neurons and how they are connected, and depending on that we make a decision, right? Similarly, the ChatGPT or any artificial intelligence is based on this large language model which has millions of neurons which are connected to each other, obviously at a machine level, right? Or at a computer level, right? So all these neurons are connected to each other, and each neuron has a specific weight which is being assigned to it, right? Now the weight is basically, as we all say, right? Higher the weight, better the preference of that neuron. Similarly, each neuron has a specific weight associated to it. That does not mean that, say, if one neuron has a weight of 8 and the other neuron has a weight of 5, always a neuron with a weight of 8 would be selected. No, it's not like that. In our case also, depending on the electrical signal, on depending upon the brain, our brain decides that which neuron I need to select, right? Depending on that, I make a decision. Similarly, there's machines depending on different algorithms or depending on the different data sets it visualizes. Depending on that, it selects the neuron appropriately with different weights, right? And all these neurons are interconnected at a mesh architecture, and that's why it's called a transformer-based architecture, right? So you can visualize this as the terminal which I just showed you, right? You put a query here. So that query is being feed into the system from the left. And then uh, from the left, once that system is being once the query is being feed or once the data is being input, it then is passed on to the different neurons, and the appropriate neuron gets selected, and then you get the responses what we saw, right? So basically, the way they do it is along with the weight, they break each word. Like say, if you have a 10 letter word, they break each word into three-fourth of that, right? So three-fourth of tenth is what, approximately 7, 8 words. So what they do is they break that words into 7, 8 words, whatever sentence you have typed, and then that words are being given to each neuron programmatically, right? Dynamically, right? And depending on that, then there is a decision which is being made back to the end user, right? I just
Okay. The battery was going down. Yeah. I hope I'm audible, right? My battery went off. Sorry for that. So, am I audible, right?
Yes, sir.
Yeah. So that's how it works, right? So it breaks all the words into three-fourth of that. So if you say what is AI, it would break into three-fourth of that, and each letter is then given to a specific neuron. And depending on the learning or depending on the different algorithms which are being built, it looks for the data which is available on the internet and gives you the most relatable answers to your query, right? So that's how it works. Okay, so that brings us to a question that why do I need, first of all, artificial intelligence and cybersecurity, right? I mean, why do I need it? And why there is a sudden need of AI? Because cybersecurity was always going on for past 6, 7 years, considering everything is going digital, everything is going on internet. Why there is a need of having an AI in cybersecurity, right? Now, the first, you would also be aware of this, that there are more increasing cyber threats which are happening now than it used to happen as compared to what was happening before. And the reason for that is basically everything is available on the internet, be it your government institution data or be it anything what you need to request. Everything you can do it from the internet with a single click, be it on your mobile phone or from your laptop, right? Which means since everything is available over the internet, the accessibility to everyone is almost the same, right? I mean, the accessibility, when I say it's the same for a normal user or to a malicious actor, right? That's the reason why you need to have guardrails or you need to have the appropriate protection for all the resources which you have deployed on the internet. Now, I'm sure you would have read this report, or at least you would have heard from your friends during COVID days. There was a rush or there was, panic among all of us to have those vaccine slots, right? And initially, I remember during 2, 3 months, there were no slots available. And many of them started using unusual ways of hacking the website, booking the slots, or blocking the slots for their relatives. But what was the other thing which was happening from an attacker perspective was you used to get a message. I mean, I've got messages that if you want a vaccine slot, click on this link. I'm not sure if you received those messages, but many of my friends received it. Even I received it. But considering having, some sense of what security is, I was not prone to clicking those links. But I think one of my friend, I remember, clicked on that link, and what happened was the attacker now then created a reverse shell or a command and control channel where he got the access of his endpoint where he clicked the link, and he did different malicious things, right? And he realized it faster. And the first thing what he did, and he was smart, he just switched off his device wherever he was operating, right? And in that case, basically whatever the connection was being established, that was being turned off, right? I mean, we all know that if I'm hosting the session, if I reboot my laptop, obviously you won't be able to visualize anything because the connection itself is not there. So that kind of threats were happening. And as per a Cloudflare report, 87% of attacks were DNS based, which happened from 2020 to 2021. And the only reason for that was everyone wanted the vaccine slots and no one was getting, and they were actually lured to click on this link. So that is one use case. The other use case, as I mentioned, that you need to protect your data, be it the organization, like as an university. Let's say, for example, all your ac- acads or all your academics, I am sure, would now be stored on online, right? Back when I was doing my engineering, it always used to be a single system where only an admin used to have access to it. And more importantly, it didn't had an internet accessibility, which means if you wanted to see your accounts, you had to go to the internet room, which we had back then, and you had to have a permission from the admin to view your accounts, if you missed your hard copies. But that's not how it works today, right? You can have your website, which is launched on the internet, and you can visualize your accounts. Not only visualizing your accounts, but you can give your exams over the internet, right? Now you need to make sure, as an institution, as an organization, or as a college, you need to make sure that the data which you are hosting on the internet is secure, and more importantly, it is only accessible to students of SSN. It's not accessible to Bhavik, who is from Cisco. He should not be able to view the accounts of other students. So it's very important to protect your data. And now most of the uh, uh, most of the network which is now moving from on-prem to cloud, right? Where you have a server which is might be hosted in AWS, GCP, or Azure. You need to make sure that that data is secure, because once your applications are hosted or in the cloud, it's accessible to everywhere, right? Over the internet, because cloud itself resides on internet. So you need to make sure that data gets protected, and you also need to make sure that if that data gets leaked, you have a huge financial impact, right? You have a huge impact on the organization. Like, let's assume that tomorrow, I'm just giving an example, but let's say that any organization's data is very crucial for them. It's not related to finance, but it can also be related to students, right? Yeah, because each student data would also carry our personal identification numbers, our PAN card, or Aadhaar card numbers, and you need to make sure that is secure, because if that gets exposed, then the malicious actors can actually play with your identification number and do malicious things. So you need to make sure that is also secure. You need to make sure that there are compliance checks as part of the data storage which you're doing. Like, say, for example, as I mentioned about the personal identification number, you need to make sure that if you're sharing it with your organization, or if you're sharing with your college institution, you need to make sure that the college institution is storing it appropriately, is not leaking it to different malicious actors, right? I'm pretty sure when you open a bank account, right, they always ask for the PAN or Aadhaar card, right? And now there's a mandate from the government that it's not necessary to give a hard copy. You can always give a soft copy in the form of Digilock, right? Where you store all the data in Digilock. And more importantly, now government is giving you a masked Aadhaar card where all your Aadhaar number is being masked. And so that even if you give a hard copy, no one can actually can visualize your Aadhaar card number in plain text. So all those compliance checks should be there. And as I mentioned that your network is of utmost important to you, right? There should always be an operational continuity. Like say, for example, you're giving your exams online, right? You need to make sure that the organization's network is all 365 or 24 cross 7 available to you. And more importantly, it's available during the 3 hours of exam which you're giving, right? Because if it goes down, and let's say you have finished 1.5 hours of your paper, and if your network goes down, who knows? Maybe whatever you wrote was not stored, and you have to start from scratch again. Or they might consider that you need to extend your, exam hours because the whatever data which you entered was being lost. So you need to make sure that the network is available, and the way it is available not only from the physical level where you have the internet bandwidth available, but also at the same time no one is attacking your network and you have the appropriate guardrails to protect that. And as last, that's what I was saying about protection against advanced threats, right? You need to make sure that since everyone is available on the internet, you need to make sure it is secure. They are not able to penetrate to your environment and do lateral attacks. When I mean lateral attacks, so say for example, I have access to your machine. Once I have access to your machine, I can have access to 10 different machines which are available in your network, right? Because all of them would be sharing the same network. The IPs would be different, but I can always run different tools to scan what are the different machines or services available, right? So these are these are the challenges which are available, and that's why there are new and new innovations which are coming in cybersecurity, that how we can prevent the threats, how we can prevent the impact of the threats to on a larger scale, right? So that's what comes to what I'm. So I would just finish this slide and then we can go for break for 10-15 minutes. But this is an important slide, right? So we just realized, we just understood that why it is important to, I mean, what is the importance of cybersecurity in our life, right? Uh, Now let's understand that what are the different artificial intelligence techniques which go in cybersecurity, right? Whatever we saw for whatever we saw for chat GPT or whatever we discussed, the underlying algorithms which I was mentioning is being built on this three different verticals. It's machine learning, which basically enables machine to learn from data which is available from internet and makes decisions like humans do it. And the way it does is, so as so think of like this, right? Let's say you have been told to write a code which prints letters from A to Z, right? So what you do, you just take Python script or C code and you just write the appropriate logic which just prints those letters from A to Z. That's it. So what you have done is basically you just wrote a code which takes a particular input or which takes a particular instruction to type from A to Z, and that's what it does, right? But as part of artificial intelligence or as part of the coders or scientists who are working in ChatGPT, rather than writing the code, they write the instructions, they write those algorithms, which basically takes the input, applies different algorithms. What you need to do, like here I mentioned that you need to print letters from A to Z, right? Similarly, it takes those 1,000, 1,500 combinations and then builds an algorithm on top of that. Obviously all those algorithms would be situation based, would be based on a specific input which you give, right? So they build all those algorithms, what are the different set of inputs which you could give, right? And it builds an algorithm for that. And when I say algorithm, obviously underlying there would be a set of code which would be written. But now the difference is what that code does is rather than just focusing on letters from A to Z, what it does is it tries to print those letters in different languages. So in this case, it just prints in English, right? But to try to print in different native languages, which maybe a particular country represents, right? So that's where the code is now evolving from a unit-based code to an algorithm-based code, and also depending on the input which you give, right? And it does both supervised and unsupervised learning, right? So what is the difference between that? So unsupervised learning is basically you gave an input, you build some algorithm, and it gave you an output, right? But how do you realize that that output is correct or not, right? How do you make sure that if a human was being asked that particular input, he would have given the same response, right? So that's what supervised learning is. So what it does is basically whatever input it gives to its algorithm or to its machines, the same input it gives to the humans, and it then checks that what is the response coming from the humans, and then it compares it with the response which came from its system generated or from its algorithm based response. And if there is a deviation, they again train the model, they again make some changes so that the response is almost close to what a human would give, right? So that is what a supervised learning is, and that's what ChatGPT did, right? Before it was brought to the world, it basically had a bunch of or thousands or thousands or two thousands of humans, where they basically whatever model they trained, they gave the same set of inputs to the humans. They saw the response and then modified the algorithm accordingly. The other is natural language processing. It basically helps in understanding machines or helping machines to think like what a humans can think of, right? So basically, natural language processing, what it would do is basically it would analyze the text and then generate a human-like responses in the way we saw in ChatGPT terminal. And the third being deep learning, right? You always keep on refining, you always keep on refining the model, right? So you always extract the raw data from the internet. Like if we give the input in search engines or we give the input in the chat GPT, you take that input in the form of raw data and then feed it to your different algorithms. So basically it learns, as I said, that the LLM model, what it does is since the neurons are interconnected to each other, it tries to give the inputs to different neurons and see what are the different probabilities of the responses which can come, and then gives and always keeps on refining its model so that the responses are almost accurate. Now, one of the disadvantage with ChatGPT currently is the model always gets changed post 1.5 years currently, right? The scientists are trying to make sure that it is more faster and always, and now there is a mechanism where in ChatGPT you can always give feedback mechanism that hey, the response which you gave was not correct, this is what was correct, right? So those kind of things they are taking it, but currently the changes gets applied only after 1.5 years, but they're trying to reduce that time gap, right? So these are the three verticals, or you say three pillars of artificial intelligence: machine learning, natural language processing, and deep learning. So any questions before we drop off for a small break? Yeah, ma'am, you can unmute them, and
Yeah, sir. 1 minute.
or I can do it. Just a minute, I can do it.
The thing is, I am in another lab.
Okay, okay, I can do it now. That's fine.
No doubt, sir.
Okay. I hope it's not boring, right? And it's not sleepy.
No, sir.
Okay, so I think it's 9:20 currently. Let's take a 15-minute break. It's fine, right? And we are back at 9:35. Is it fine?
Yes, sir.
Okay, perfect. So yeah, let's reconvene at 9:35. Okay.
Yes, Pavit, sir. Sir.
Yes, sir. We are all ready, sir. We can.
Okay, sure. So yeah, I hope everyone had a good breakfast. So we just before we dropped off, right? We discussed about the different AI techniques, right? So now moving on to the we realize that why cybersecurity is important, right? Now we would focus on what are the traditional cybersecurity approaches, right? Now, why, I mean, we are just now going to that direction, trying to understand that why do we need artificial intelligence in cybersecurity, right? Now, before that, let's understand that what are the traditional cybersecurity approaches we have, right, today. So the first is the signature-based detection, which we have, right? So what I mean by signature-based detection, have you heard about Yara rules? I mean, even if you have not heard, I'm sure many of you would have at least visited the Virus Total website. So Virus Total website is nothing but it basically tells you the different malwares or the different threats which are appearing in different samples, right? Now, these threats appear in different samples in the form of files or any medium it can come through, right? Or maybe the malware can be hidden on the websites, right? So in a traditional cybersecurity approach, what signature-based detection does is basically in an intrusion prevention system. So they are nothing but basically works on the application layer, right? Now, uh, in our OSI layer model, everyone you would be aware of the layer 4 which is called transport layer, right? Which is basically TCP and UDP, right? There are several ports, source IP, destination IP address, on which the connection gets established, correct? Now, similarly, on an application layer, there's no concept of IP address because that is taken care by the layer 4. So on layer 7, basically, most of the detection happens at the application layer. Now, when I say application layers, let's say you have an HTTP request going on. So at there you have a GET request which is being sent. Now, as part of the GET request, there's a GET header, and there are different HTTP headers which are part of that. Like if you have a GET request, there would be a specific header number, numeric value which would be assigned to it. Similarly, if you have a response, you have a 200 OK response, which means the response went through successfully. So all that application, all the signature-based detection works on the application layer data, like what kind of data is being transferred as part of the different applications. Like in this case, it's HTTP. Tomorrow it can be some other protocol like Quick, right? So it basically looks for the data patterns in that, which is obviously, if you would have seen, all the data is in hexadecimal. So it looks for the patterns for that data and then builds a regex on top of that, right? That's what we say a signature-based detection. So say, for example, a GET request is supposed to have a pattern of say A at the start, right? But if it sees a pattern which is B, it then flags an alert. So that is what we call signature-based detection mechanism. Now, the reason it is not trustworthy going forward is because now there are malware, because there are attackers who are also becoming smart, right? They know what are the intrusion detection mechanism or prevention mechanism which is available in your network. So in order to basically bypass that, right? And the attackers also keep on learning new techniques, right? So what they can do is they can use AAAA as the initial mechanism, but in between the payload, they would apply some malwares, right? So as part of a signature-based detection mechanism, it would feel that, okay, it's a valid packet, but it does not look at the entire payload. It just looks at the part of the payload and decides that, okay, this is a valid payload and should be, allowed in the network. So that is one problem. The other is most of the traditional cybersecurity approaches were reactive, right? Now, when I say reactive, is like the problem happened, post that you do the analysis, and then you refine your defense mechanisms, right? So, if I have to give you an example, it's like, let's say there is a terrorist who is trying to, barge into your country and create havoc, right? So as part of a reactive defense, what would happen is the terrorist enters your territory, enters your border, reaches the destination network or the location where they want to create an havoc or create an attack, And that's where you block them, right? You realize that, okay, the terrorists have now entered your territory. Now you refine your defense mechanism, make sure that the impact is as minimum as possible. So that is another problem, reactive defense. The third is, as I said, that manual analysis and response. So all this cybersecurity approaches, right? And all the organizations have a threat intel team which works at the back end, which looks at different samples which are available on the internet, right? Different samples in the form of what are the different file hashes which are getting transferred over the internet, and it looks at that and then basically does a manual analysis and then builds the rejects out of it. Then it basically, so all whenever a sample is given to you, right, as part of a researcher, there are two things you would do. You try to understand what that sample is doing, and then write basically a rejects based rule, and which would detect this, that this sample is being sent, right? If it is malicious, you want to make sure that before it penetrates a network, it should be detected as soon as possible, right? So that is another problem. Again, I won't consider manual analysis. The reason I put here is because just to make you understand that how the threat intel works at the back end. Even with AI in cybersecurity, you'd still need those manual analysis, right? Because there would be new samples which would be coming in. Your machine, the algorithms which you have built as part of the automation or as part of the AI, is not going to detect the new threats which are coming in, right? You need some kind of intelligence. You need some kind of manual intervention to understand that, okay, is this the algorithm detecting correctly or not? So that always goes hand in hand. So your manual analysis is not always going to go 100% off, but maybe as I said, that the example which I gave you, right? The code which I had to write in 7 days, which we decided to write in 7 days, was done in one day, right? So that we can put our 6 days efforts in something else. That's how this would go, right? Let's say if a threat researcher was analyzing, say, 100 samples on a given day, now he would analyze, say, 40 samples, 50 samples, but he would try to do something different than what the AI is giving to it, right? So that's how the productivity would also increase. The other is, in my traditional approach, you don't have contextual understanding, right? You always think from a network perspective that this traffic entered my network, that's it. It tried to access some applications, and maybe one application went down, two application went down, three application went down, right? But you never build that contextual understanding. You never build that relationship, that how did that application service went down? What was a trigger? What was the entry point? What was the exit point, right? So basically you don't have the visibility. Like I mentioned, right? The terrorists entered your territory, but you don't have the visibility from how did they enter? How did they enter the border? Obviously, as part of a reactive approach, you always look back and look at trace their entry point, right? But if you had a visibility from the start that, hey, someone is entering, they would have alerted, so that rather than entering the territory, you would have blocked them close to the border rather than, penetrating them inside your territory and creating and allowing them to create those havoc. And the last is, as I mentioned, right, limited visibility with traditional approaches, because when you look at the cybersecurity, right, there's so many point products which does some function of it, right? I'm not going in depth on that, but just to give you an example, right? Every day, when you enter your college, right, you have your iCard. Obviously, you don't want to swipe somewhere, but some you have the security card where you enter your registry, right? So there is always a constant visibility, that who's entering, who is going out, right? But let's say tomorrow I am a faculty, right? I am from Cisco, and let's say I happen to visit your organization, or sorry, your college, right? What I would be given is a temporary gate pass. And the security guard says that, hey, this is a building where you want to go, and this is a classroom where you want to, where you are supposed to deliver the lecture, right? But which means the security guard is assuming that I am going to go to only that dedicated classroom. But what if I have malicious motives? Again, I don't have, but just for example, what if I'm not going to that classroom? I want to just look at the entire campus. There's no one who is looking at me, right? The reason is being there is a gate pass which has been issued to me. Yes, there are CCTV cameras, but there's no one who is going to stop me that, hey, you are supposed, or there's no one who is authorizing it that you are supposed to go to classroom A, but you're roaming around to different buildings or different campuses, which you're not supposed to, right? So that is another problem. You need to make sure that if a person, a third party person, is supposed to enter the classroom and leave the classroom, that's it. He finishes work, leaves the classroom, goes to his home. You don't want him to roam around different campuses, even though I am from Cisco, but there's several compliance checks or the security checks which you want to do, which is being lagged by the current cybersecurity approach. Does it make sense? Okay. So that brings us to what are the applications of artificial intelligence in cybersecurity, right? As I mentioned, the first is threat detection and prevention, right? We would look into one real use case which happened actually to Cisco. Uh, and how did we prevent it? I'm sure you would be aware of that, but again, even if not, we would just I would walk you through that. But the first application is a threat detection prevention, right? And more importantly, not having a reactive approach, but having a predictive approach, right? That before a threat is supposed to happen, you are basically alerting all the network admins or all the appropriate authors or the appropriate whoever has the responsibility of securing your network. You're basically alerting them that, hey, there's something malicious is going to happen or is about to happen. Make sure you do this thing, right? So that is a predictive approach, which where AI can help. The second is anomaly detection, right? As I mentioned, anomaly detection is like, say for example, let's say there is a user, like you log in. Let's say you log in daily to your organize or your college network, and let's say your daily task is to download, right? Let's say your daily task, you have, let's say there's an application where you can download your accounts, just for example, right? And as a normal user, what you do, you generally download your academics, right? Or maybe you download academics of your best friend, right? But what if you try to download academics of past 10 year students and also get also download their personal details which are being stored in the college website. Again, assuming that you're able to hack it, you're able to get details which you're not supposed to. That is where an admin can be alerted, right? That, hey, this user is something doing abnormal, which he's not supposed to do. And if he's doing, how do you detect it? How do you block it then and there and not wait for them to download all bunch of data, create those damage, and then you alert the network admin, right? It is more about doing at the same time when the attack is happening, right? The third is user behavior analysis. As I mentioned, the example which I gave, right? If I enter your campus, right? And if I'm supposed to enter classroom A, right? As per the gate pass which has been issued. Now, if I roam around the entire building, that is not how I'm supposed to behave, right? I'm supposed to go to a specific classroom, deliver my lecture, and get out, right? But that is not what I'm doing, which means there should be someone who should be alerting the security guards that, hey, the person whom you have entered seems to be roaming around. Just make sure that you um, uh, alert him, not alert him, just drag him and say that, hey, you are not allowed to roam around. Just go back to the classroom where you're supposed to deliver the lecture, right? The fourth is malware detection. As I mentioned, that what if, as a professor, I bring a USB stick, right? And I enter into your network laptop, right? Which has a malware in it. Now, as an cybersecurity or in order to provide security, you need to make sure that the two things, right? The malware should not be downloaded. First of all, the USB should not be detected, right? If it is an external USB stick, and even though and more importantly, it's a personal USB stick from which I have brought, right? So it should be detecting that. It should not be allowing it to I mean, it should the endpoint or the laptop where I'm inserting, it should not be detecting the USB stick for the first thing, right? Now, let's say it allows a USB to be inserted. The second stuff is it should not allow the malware payload to be downloaded on the endpoint system, right? And the way you do it is basically you have different agents installed on your endpoints or your organizations or on your university endpoint systems which are governed by them. You have different agents which detects this, which detects that if there's an external USB stick, block it there and then, right? And the fifth most important is the incident response and investigation. Whatever we talked about, the 4 points, right? Threat detection, visibility, the last thing is what do you do once you detect something is maliciously happening, right? That's where the incident response and investigation comes in play. That you detect something, you are being alerted. Now you need to restrict it then and there, right? As I mentioned, that if there's a USB stick which has been detected, make sure the payload is not downloaded. Even if the payload is gets downloaded, you make sure that the endpoint PC is not able to communicate to different pieces in the same network, right? Because it would try to infect other machines and it would create a havoc in your network, right? So these are the different applications which is where AI can come and play, right? Any questions here? Okay. So this is one of the secure AI framework which Google has given as part of its AI platform, which with the name called Chronicle, right? So Chronicle is the AI framework which is being built by Google, and basically it is for professional use, obviously, and they sell it to enterprise network. So these are the 6 points which Google came up with. Again, this is not the standard, but I just wanted to highlight that, okay, what are these are the common pillars across which all the any organization which builds its AI product would be based on. So the first is expand the strong security foundation to AI ecosystem, right? What does it mean? So you would have came to know that artificial intelligence does not work on its own, right? You need to input something. So when we saw it chat GPT or when we saw it the search engine, you input something, right? There's no magic which is happening where the machine would just give you some vague responses, right? It needs some input and it would give you an output. Similarly, when you talk about AI in cybersecurity, the input which you get is the different security solutions which you have deployed around it, right? So say, for example, the simplest example which I would give you is your university campus would be having CCTV cameras, right? All those CCTV cameras, what do? They capture the feed and there's a centralized server where you can view it, right? A particular network admin can view it, right? Now, what it would do is it would feed that data to an AI system, which would look at the patterns and the time intervals, the particular location at which what are the probabilities of different persons visiting that site, right? So today it's a student, tomorrow it's a lecturer, day after tomorrow is some scientist, right? But what if there's some other person who is visiting that site, right? And it has never seen before, right? So what it does is it as part of the data which is being fed to the AI system, it would alert the network admin that, hey, even though you have CCTV cameras, even though it is capturing what it's supposed to, I feel there's some not malicious, but there's some abnormality which I'm viewing it, where there's some a person which has not entered the university till date is being seen here at this particular location, which ideally we have never seen before. So would you like to have a look, right? So that is what it says, right? So you need to have the existing security solution data should be fed to the AI ecosystem, and then it basically builds the patterns and then alerts you accordingly, right? That's what we say, extend detection response to bring AI into the threat universe, right? So each of the organizations, right? All the organizations, like when we say Google or say Cisco or different vendors, right? All the OEM vendors have its dedicated threat research team. So what does it do is basically it looks for all the samples which are available on the internet. It tries to build a pattern and then alerts you that, hey, if you see this file sample, if you see this hash value, it looks to be malicious, right? So the existing security solutions which are there should be integrated to the AI, and also you bring AI to the your threat intel platform that basically collects all this data. It collects the data from the internet, it collects the data from your network, and then alerts you the different threads, the new threads which are coming in, so that if you see the same thread in your network, right, in your organization, you are alerted before it is being attacked, right? And as I said, that you need to automate the defenses, right? Because now, as we see in the later slides, the attacker can penetrate your network not from the front gate of your university or not from the back gate of the university, but it can penetrate from any gates, right? Maybe it can climb your wall, right? Which is practically impossible. But just to create an analogy, when I say climb the wall, basically, if you have any resources which are available on the internet, it can attack it using different attack methodologies, right? So you need to make sure that you automate those defenses, alert the network admins, and create those templates that what needs to be done if this particular attack happens, right? And you need to have consistency across different control frameworks which you have deployed for your AI for risk mitigation, right? When I say consistency, you create different templates as per you, right? That if you see that there is a, like I mentioned, that if you see a difference in pattern, if you see a particular visitor who is not supposed to visit a particular building, what you do, right? So you create those consistency rules across all and feed it to the AI systems, and you adjust the mitigations and create faster feedback loops, right? As I mentioned that AI, there would be a possibility that AI can generate a false alert. So that's where the feedback loop is important, where you, as a network admin, you say to the AI that, hey, the alert which you generated was not correct. And this is where you need to improve, right? That's what ChatGPT also did. And you also need to have automatic checks to validate the AI performance, right? So you basically look at the set of actions which was taken by artificial intelligence tool, and then you compare it with the manual approach, what you would have taken, right? And if there is any deviation, you always give the feedback so that your AI system gets refined. Okay. So this is what I'm sure you would have seen a specific IT network, right? So let's say on the left side, there are users who are in your university who are trying to access different applications over the internet, right? And that's what you see on the cloud. And there is a perimeter security firewall, and all the traffic towards the internet gets inspected by the security firewall, and then it is forwarded to the applications which are hosted over the internet, right? Now, this was a traditional IT landscape. Now, why I say traditional? Before COVID, right? Before 2020, everyone, I mean, obviously, you did not had a choice. You always had to come to university. Obviously, during COVID, there were remote lectures, but even in a professional world, everyone was working from office. There was no such concept of working from home. Obviously, maybe in 1 or 2 odd days you would work from home, but generally you used to work from office, which means that you knew that from where the traffic was getting originated from, right? You always knew what was the entry point, what was your exit point. That's why your security, right, and the kind of applications which are hosted on the internet were limited, so you knew where to deploy a security solution. It was more, the scope was limited. But with the onset of COVID, with the kind of applications which are moving towards the cloud, the perimeter is no longer restricted. The scope has just expanded. That's what you see on the right side, right? There's so many application devices. Like as an individual, you would be carrying, say, 4 devices, be it your smartphone, be it your smartwatch, be it your laptop, be it your iPad, right? You have so many so many devices, right? Because, and the reason because for that is now you have internet, you can access internet, you can access any information from anywhere, right? Which means your traditional parameter security, which was where the scope was limited, now it has expanded, right? And that's where I talk about this, right? Defense in depth. So pre-COVID or before COVID, right? Where the everyone was working from office, we had this defense in depth mindset, right? So let's consider this palace, which was your university. And I always knew that there was a risk, the scope was always limited. Like any visitor would be coming from the front gate, and they won't be climbing the outer walls, and I would all have all my security solutions at the entry point, right? Or maybe at the exit point. But with the onset of COVID and with the applications moving towards the internet, now you can see that the attacker, there's no longer restricted access, right? He can climb the wall, or he can have the visibility of what is hosted at the building, which is at the back, right? Which is highlighted here, right? Rather than coming from the front gate, he can enter from the back gate, not physically, but over the internet, right? Because eventually it would try to exploit the resources which are hosted, or the different applications which are hosted over the internet, right? That's why the traditional or the defense in depth approach no longer applies here. And you need to have a constant visibility. You need to have different AI mechanisms, because there are so many users who would be accessing your data. You need to have some automation there to understand that, okay, who is accessing what, and is he authorized to access that or not, right? So that brings us to a zero trust architecture. I know when we talk about AI in cybersecurity, right? All those principle also gets applied here. So uh, have you heard about the zero trust architecture, which was coined by Gartner? So Gartner is nothing but an institution which every year comes up with different security frameworks which all organizations should align to. So in this case, zero trust. So what zero trust means is never trust anyone. Okay. So what it says is never trust anyone, always verify, right? Which means that the example which I gave you, right? As a lecturer, say I'm entering your university campus, and if I'm supposed to enter campus A or building A, there should not be an implicit trust on me that I would only be visiting that building. I am free. There should not be implied trust on me, and also should not be assumed that I would just be visiting that campus. As I mentioned, that I it might be possible that I would be roaming around in the building, right? So that's where the zero trust concept comes from. It was always there before also, but with this onset of different applications which are coming in, that's when now more importance is given to zero trust, which says that never trust and always verify. And these are the pillars, right? Where the zero trust mechanism should be applied. One is the identity, as I mentioned, that are you the user? Are you the user authorized to access this, right? Let's say, for example, if I am a student of a university, I should be having access to all the rooms in the campus. Whereas if I'm a lecturer, I should only be having limited access to the campus building. Similarly, the devices which you bring, the mobile phones or the smartwatches which you bring to your university campus, are they aligned? Are they do they have the most recent version downloaded of the operating system? Are they having any malwares installed in their mobile phone? So all that posture check you need to make sure is being done, right? Then the network, right? You need to make sure that the network through which they are accessing the different data is secure. And if it is being attacked, you make sure that there are appropriate defenses in place to make sure the attack is never expanded on a larger scale. And as I mentioned, that there are different workloads which gets deployed either on the cloud or on your on-prem network. They need to make sure that those workloads are protected, right? Be it on the cloud or be it on the prem, and the data which gets transferred on as part of this applications, you need to make sure that the data is secure. As we saw in previous slides, if the data gets leaked, it's a privacy the privacy data, if it gets leaked, it can cause multiple, repercussions on the end users health, or on the personal data, which can cause financial impacts, right? And last but not the least, you need to have visibility, end-to-end visibility of what is happening in your network, right? As I mentioned, that if there is a terrorist who is entering from the border, you need to have a visibility from there and there, that okay, there's someone trying to enter my border. I need to restrict them there and there, right? Rather than allowing them to enter my territory. So all the principles of this AI gets aligned to zero trust, and then you build the security solutions around it, right? Okay, so coming up with this example, right? So I already gave you the hint. So this attack actually happened to Cisco, right? I think 2021 during COVID, right? And it just tells you that I mean, an organization like Cisco can also be duped, right? And in this case, yeah. So in this case, basically, you can see that what happened was there was this employee like me, right? Uh, you was syncing his password to a Gmail, right? We all have this browsers, right? On the browser, on the Chrome browser, you have this option of syncing everything, syncing all your data to a Google repository, right? In this case, the user like me, who was a Cisco employee, sync the password on the Gmail, right? Sync password means it syncs password to all the user websites which you're doing, right? Which also includes your corporate websites where you're entering your corporate username and password, right? So as part of a university student, you would be having your username and password to log into your portal, right? Similarly, all employees in Cisco have their own username and password, right? Which is tagged to my identity, where I can use it to view my pay slips, which I can view to use my grades or promotion cycles, right? So, and also different applications which only I can access, right? So, though he was syncing that password, right? Now, what happened was his Gmail account got compromised, right? Maybe the Gmail credentials were exposed to dark web, and this attacker basically purchased it from dark web and got his username and password, the corporate username and password, right? Now, what he did was, once he got that, now he tried to open a particular Cisco website, right? So we, as part of an organization, we have internal websites, right? Now, let's say in this case, he tried to open an application where where internal data of Cisco is available, right? He opened that. Now, as part of a zero trust, all our applications require dual factor authentication, right? Even Gmail nowadays requires dual factor authentication if it detects you are trying to log in from different location, right? It asks you to enter a numeric code. Unless and until you don't do it, it does not take you forward, right? Similarly, in this case, he tried to open that application, now which triggered a MFA, dual factor authentication. Now in dual factor authentication, if you know, what happens is the numeric code is being sent to an authenticator device. What is an authenticator device? It's a device which can be a mobile phone on which that application is being installed, right? So that numeric code would be visible on that. And once you enter that numeric code, so basically the way it happens is, let's say you are opening google.com, right? What it does is google.com forwards a request to a two-factor authenticator. It can be, there are different OEMs which provide that, right? So it redirects a request to that. You see a four-digit code on your laptop screen, and you need to enter the four-digit code on your authenticator device, which is your mobile phone. And if that gets validated, you are allowed to access that application. Clear? Now, in this case, the attacker did the same thing. He opened the application, and what was happening is, initially, before this attack, the way it used to happen was, the moment you open the application, it used to trigger a dual factor authentication, where it won't show you the four-digit code on your screen, right? What it used to do is it would just send the dual factor authentication on your authenticator device, and you just need to approve it, right? And there was only a tick or cross, right? So in this case, um, the attacker did that, right? He opened that application, it triggered a dual factor authentication on the authenticator device of that employee, right? Now, the employee, in this case, he did a MFA fatigue. Now, what do you mean by MFA fatigue? Imagine uh, someone is calling you, say, at in 1 minute, you are getting one call, right? So you'd receive, you'd speak to him, all done. But let's assume that in 1 minute you are receiving 1,000 calls, right? Repeatedly, right? You got one call, second call, third call. So at the best, what you do, either reject or accept, right? Similarly, in this case, he got 1,000 or 1,500 requests at one go, right? Now, maybe he was in some meeting or whatever, right? He just clicked on accept on one of them, right? The moment he clicked on accept on that, the remote attacker got the access of the Cisco network, right? Because um, uh, he had a VPN access. I'm sure you would be knowing about VPN, right? VPN is something you connect to VPN and you can access private resources. In this case, he got access to that VPN because he had the access to credentials and now he had the MFA authorization was also successful. The moment he got that, what he did was he tried to he implanted or from his endpoint machine, he downloaded some malicious scripts on the user endpoint on the corporate laptop, and from there he started traversing different application servers in the same network. Maybe he ran different nmap tools to understand what are the different services running on different application servers. And once he realized there were critical database servers, he tried to do lateral attacks on that, right? But luckily, we had defense in we had different agents which were installed on those application servers. And the moment there was some anomaly detected, this user was put in an isolated VLAN. What do I mean by isolated VLAN means? There was literally no access to the network where the attacker can do lateral attacks, right? So basically from that endpoint machine, all the remote machines were unreachable once it was being detected. And because of this different endpoints installed, what we covered before, right? That, okay, if the attack happens, you should be faster enough to detect it and prevent it. And that's what we did. And in this case, we were lucky enough because of the in-depth security mechanism which we had on our endpoints on our network. The attack was not the attacker was not able to extract any critical data, and more importantly, it was not able to affect any other critical application service, right? But this was a learning for us that the so what were the learnings here is, as you can see, that the first thing is, yes, from a user perspective, you should not be syncing the password, right? And it's a learning for us also that, I mean, post this, I have stopped syncing my passwords through Gmail, and I believe you should also be doing the same. That's first. But the most important thing is the dual factor authentication which we had, right? One of the flaw in that was, as mentioned, was when you used to open any application, there was never a four-digit code which used to appear on the laptop screen, right? Which means that as a part of a authenticator, when the MFA request used to come to me, there was always a checkbox, there was always a accept or reject, right? I never had a context of who initiated this application, what was the application for which this MFA request was being raised. Suppose this we made changes that now we have a four-digit code which appears on the laptop screen. Now, how does it help, right? So imagine in this case, the attacker opened some application, some Cisco website. There is a four-digit code which appears on his screen, right? Now, the same four-digit code needs to be entered on the authenticator device. Now, the authenticator device is something the employee would be having, right? The attacker won't be having the visibility that whether he's entering the attacker won't have visibility of the authenticator device. Similarly, the employee won't have the visibility of the four-digit code which is being seen on the attacker machine. Getting it, right? It's something like let's say you have your colleague's phone, right? And your colleague's phone, uh, we have this four-digit code lock, the screen lock which we have, right? Which only your colleague can open. You cannot open, right? Yeah, yeah. Obviously, if you know that code, that is a different thing. But let's say if you want to hack into his system, into his phone, you need to know that four-digit code. Similarly, in this case, the attacker knows what is a four-digit code appearing on his screen, but he cannot enter it because the authenticator device is with the employee, right? So that was one way where this fatigue attack was being prevented, because the authenticator device needs to validate what is a four-digit code, and the employee does not know what is that four-digit code because that application, that request was never launched by him, right? So that is the way, that was one of the improvement which we did as part of our dual factor authentication. And I would show you this. Yeah. So as you can see, this particular is a duo mechanism, the fingerprint icon which you see here. So that was one improvement which we did. The other improvement which we did, right? We always do the posture check on the source machine who is initiating the request. Now, what do you do on the posture check? You basically look at the health of the endpoint, whether there is any malicious script which is being installed on that endpoint. Are there any security settings which has been disabled on that endpoint? And if you detect something like that, you would it would basically restrict that user from accessing that application and would give you a prompt that, hey, it seems that your security score is very less of your endpoint. Please fix this before you can access this applications. So those were the two improvements which we did. And as I mentioned that even if the when the attack was happening, the reason it was not able to perform lateral attacks was there were different EDR agents. EDR is nothing but endpoint detection response agents which were installed on the application service, which prevented the attack from uh, blocked the attack, or which prevented the attack from happening to different critical application servers, right? So EDR we always had, but this was the improvement which we did on dual factor authentication, right? So this basically tells you that how it is important to have different security mechanisms in play, right? And now you would realize that, or you would ask this question, that where would AI fit in this, right? Now, the way AI would fit here is basically there are different, it would look at the different behaviors of what did the attacker did when it penetrated the Cisco network. And depending on the kind of actions he did, it would create an algorithm around it, and would say that if in future those similar commands are being entered, which means there's some attack which is happening, we need to alert the network admin, and also at the same time give him the set of guidelines how to prevent those attacks from happening, right? So this was something which happened in our case, and when this attack happened, in next 12 hours we had to reset our passwords, I mean twice or thrice, right? So that is the way, I mean, that was something, a predictive prevention which we did, where we saw that there was an attack happened. Now, to make sure that the attack does not gets repeated to other employers, we were asked to reset our passwords, right? So that's how it happened in this case, and this is a valid use case, right? It can happen to anyone, right? Okay, so that brings us to the end. So go back to the menti.cisco.com, this one, and there are several questions. Okay. Yeah. So go back to this. Yeah, go back to this menti.com. There are a few questions I would like you to answer. The same code. Yeah. So yeah, I could see few answers coming in. So can you please answer yourself? Perfect. Someone is saying OpenAI, someone is saying Bard. Oh, okay. And this is while I was discussing the session, I gave the answer somewhere. So if you're listening carefully, Would be getting that. Oh, there's someone who is saying ChatGPT. Nice. Okay. Is that the one? I think there are more than 15, right? Okay. So yeah, most of them got it correct. So it's Bard. It's not OpenAI. So OpenAI is from Microsoft and the founders of OpenAI, I think Tesla Motors. But yeah, the Google came up with its own model, Bard, and OpenAI is itself ChatGPT, right? And Bing is from Microsoft, where they're integrating Bing with ChatGPT. Okay. So Bard is correct. Perfect. Next, what are different pillars of zero trust? So we discussed this at it was at the last few slides of our session. So what are the different pillars of zero trust? Is it endpoint, wireless, application and data security, or orchestration? Okay, someone is saying endpoint. Someone is saying application and data security. Okay, so I think most of them got it correct. Yes, it's application and data security. The other pillars is identity, network security, and data. Yes, that's correct. And the last, how does AI help in threat prevention? Is it reactive approach, defense in depth, predictive approach, or faster response? Hmm. Okay, so someone said predictive, someone is saying defense in depth, someone is saying reactive. Hmm. Yeah, so most of them are saying defense in depth. Okay, someone is saying predictive. Okay, so I believe this was a bit tricky one. Uh, yeah, I mean, those who have answered defense in depth, yes, AI helps you in giving you a defense in depth, but if you understand the palace analogy which I gave, right? That defense in depth is about the scope is limited, where you know who is your entry point, who is your exit point, right? But where does AI help in is since now the perimeter is thinner, is no longer uh, stitched to the enterprise network. It's now basically the network is everywhere, right? Which means the way AI can help you in threat prevention is by a predictive approach, right? Because defense in depth was always reactive, right? That along with the limit, along with the scope was limited, you always, uh, the attacks were always used to happen, and then you used to build your defenses around around it, right? But AI, the reason it helps is more predictive, right? Before the threat is going to happen, it gives you that edge that hey, there's something which is going to happen bad, do this so that it's the attack does not expand to other network, right? And as I mentioned, reactive approach is more a traditional approach which we used to take, but now it is moving. The needle is moving towards a predictive, and that's where the AI helps. So yeah, I mean this was a pretty tricky one, but yeah, predictive approach is the right answer, right? Okay, so I think that's it from my side.